Hello, everybody. Welcome back. And we are going to look at day 2 of 8.5. We're going to talk about solving problems using trigonometry, and then also how do we solve area problems in triangles using trigonometry. So first, we're going to look at setting up problems with trigonometry. You're going to want to learn how to draw out the problems, because drawing pictures is going to be worth 1,000 words. Okay, so make sure you can learn how to draw problems. I've already kind of pre-drawn this problem for you. So Sarah sights the top of a Statue of Liberty at an angle of elevation. So that's the first thing you want to kind of pick out, is we have this angle of elevation. So if you recall an angle of elevation, we're kind of looking this way from horizontal, and then going up from that angle is 61 degrees. Okay. Sarah is 5.5 feet tall. So right here, this distance right here is 5.5 feet. And the reason we need that is because her eyes are not on the ground, right? They're up off the ground. And so we want to find out how tall the Statue of Liberty is. So the Statue of Liberty is x plus 5.5 feet. So we need to find that distance of x and then add 5.5 feet to it. Okay. The distance she's standing from the base of the statue here is 166 feet. Okay. So first of all, this is a tangent ratio, because we have our ratio, our angle here, our opposite side and our adjacent side. So we're going to use tangent ratio. So tangent of 61 is going to be equal to x over 166. If I multiply 166 on both sides here, then we can find out our distance from the base. So 166 times the tangent of 61 degrees is going to equal our x, and that's going to be my height, well, part of my height, actually. So let's come over here to our calculator. So I'm going to have 166 times my tangent of 61, and always, again, make sure you close that parenthesis, and that's going to be about 299.5. I'm going to round that, so x is about 299.5 feet. And of course, to find the height of the statue over here, we have to add 5.5 to that. So x is going to be 299, or sorry, not my x, my height. Sorry about that. So my height of my statue is going to be 299.5 plus 5.5. So we're just going to take this guy and just add a 5.5 onto it. And that will give us our total height, about 305 feet, right? So my height is going to be approximately 305 feet for the Statue of Liberty. Okay, and that's how you set up your problems, applications. Okay, so this one I don't have a picture on here, so we're going to have to set it up. So a spectator sits in the stands. A spectator in the stands spots a team mascot on the field at an angle of depression of 46 degrees. So let's go ahead and we'll just kind of, we've got us some stands over here. And we don't need to draw the whole stand. Let's just pretend like here's my visitor, my spectator in my stands. And here's my mascot on my field over here. Maybe it's a bear, whatever, I don't know. Okay, so he spots this mascot over here somewhere, right? And it's an angle of elevation. So here's my horizontal sight if I look straight out. And here's my 90-degree angle right there, okay? And so my angle of depression right here, so going down, is going to be 46 degrees. Okay. If the spectator is sitting 35 feet above the ground, so that's going to be here, it could be here, it could also be over here. So 35 feet on both sides, 35 feet above the ground. What's the horizontal distance between the spectator and the mascot? So that could go here. It could also go down here. It doesn't really matter. What matters is that you set your proportion up right. So I'm going to use this triangle up here to set up this trigonometry problem, because I already have my angle inside that triangle. If I use this triangle down here, I'd want to make sure I get the correct angle that's inside here. So I want to take 90 minus 46 and use that here, right? And so I want to be careful with that. So I have a tangent ratio here. So I'm going to use my tangent of 46 is going to equal 35 over x. Okay, my opposite over x. So then again, I'm going to multiply x over here. X times tangent of 46 equals 35. And of course, you guys probably do this in a faster way, but I'm taking every step. So I divide by tangent of 46 now. So it's going to be x equals 35 divided by tangent of 46. Okay, so let's get our calculator here. Clear this up. So we have 35 divided by, and I'm put this in parentheses because it's going to be in our denominator. Let us know that everything is in the denominator here. So tangent of 46, I'm going to close the 46 degrees, and I also have to close that denominator. So I notice I have 2 parentheses right there. Okay, enter. So I have 33.8. We'll round to the 10th. So I have x is approximately 33.8 feet away is the horizontal distance. Okay. Okay, so let's talk about area. Okay, so how do you use trigonometry to find the area of a triangle? So if I were to draw an altitude in here and call it my height, okay, my area of this triangle right here would be 1/2 b base times my height, h. Okay, and I have that written over there already. So also I know that my sine of A right here, right? My sine of A right here would be sine of A is h over c. My opposite over my hypotenuse of this triangle right here. I'm going to kind of write that in this triangle right here. Okay, that's right triangle. So opposite the sine of A would be h over c. Well, if I multiplied c on both sides, I would get my h equaled c times sine of A. Okay, so now if I take this h up here and I plug it into this h right here, I'm going to get A equals 1/2 b times c sine of A. Okay, that's my area. I'm sorry, area. Okay, so my area is going to be equal to 1/2 b c sine of A. Okay, and so that's my formula to find area for that triangle. So notice that if I take the sine of A, I'm multiplying by 1/2 times BC, the two sides that make up that angle. Okay, so my area is going to be 1/2 of the two sides BC and the sine of the angle between those two sides. Okay, if I wanted to find, if I had my angle C, so I had sine of C, I'd want to take 1/2 times A times B, sine C. Okay, if I had my angle B, I would take my sine of B, and I take 1/2, and I multiply the two sides that make up that angle. So times A times C, sine B. So that's how I would find the area of any of that triangle. I would take the sine of whatever angle, and then multiply 1/2 times the two legs. So 1/2 times A, C times B times sine of A. Okay, so looking over here, here's my formulas. Okay, so again, if I have angle A, I would take the sine of A and then multiply 1/2 B times C times sine of A. If I had my angle C, I'd take 1/2 times A times B times the sine of C. If I have my angle B, I would take 1/2 times A times C times the sine of B. Okay, so let's put this to use here. Okay, so what is the area of FEG? Well, notice that I have my angle E. They tell me that F is equal to 4 centimeters and G is equal to 3 centimeters. So I have my two sides that make up the angle. Oops, I don't know what happened on my screen. There we go. All right, so then all I have to do is say area is equal to 1/2 times my two sides that make up the angle. So 4 times 3 times the sine of 1/16. Okay. And so I can go ahead and take my calculator, and we're going to go 0.5 times 4 times 3 times the sine of 1/16. Plug that in there, and we get about 5.4. So the area is approximately equal to 5.4 centimeters. As far as work goes in your homework, I need to at least see this right here. Okay, I need to see that set up and then your answer. All right, let's look at another. Now, what is the area of JKL? Well, we have angle J, and so we're going to use these two sides. So we're going to have our area equals our two sides, 9. Sorry, we got the 1/2 times 9 times 15 times the sine of the angle between them, sine of J, 51 degrees. Okay, so again, we'll just come back here. We're going to take 0.5 times 9 times 15 times the sine of 51. And that gives us 52.5, about 52.5, okay? So my area is approximately equal to 52.5. And there we go, okay? And that is how you find the area of a triangle. Let's try one more. Maybe you try this one and see how you do. My area is going to be equal to 1/2 my two sides that make up my angle, 10 times 12 times my sine of 72 degrees. Okay, get our calculator out. We have 0.5 times 10 times 12 times my sine of 72. And that's going to give us 57.1. So my area is approximately equal to 57.1. There's no units there, so we don't really have them. Okay, and that's it. So make sure you draw pictures for your area problems. Make sure you know all these formulas for area, which is quite simple. If you just take, whatever sine of your angle is, you multiply 1/2 times the two sides that make up your angle times the sine of that angle. Okay, and then you guys have an Excel in Google Classroom, and I will see you all soon. Take care. Bye-bye.